In this video, we're going to solve an equation using logarithms. So again, our first step is to isolate the exponential. So I need to divide both sides by 50. And I'm going to be left with this e raised to the 0.25t. And that's equal to, I guess, 90 over 50. Okay. Step 2 would be to take the log or natural log of both sides. So since there's an e in the problem, I'll use the natural log. So natural log of e raised to the 0.25t equals natural log of 90 over 50. You can actually drop the zeros and just write 9 over 5. I kept the zeros for this problem, right? But you could cross out the zeros here and just leave it as ln of 9 over 5. Right? The third step is to rewrite using properties of logs. All right, so I can essentially take my exponent and write it in front of my log. So the 0.25t was the exponent up here. And that's going to be in front of the natural log of e. And on the right side, we do not change anything. Okay, and just as an aside, remember the natural log of e is equal to 1, right? So I can essentially cross this out because that's the same as saying 1, right? That's the same as saying 0.25t times 1. So really, let's just clean this up, and you have 0.25t equals the natural log of 90 over 50. Okay, and then the final step would be to divide both sides by 25 to isolate the t. Okay, so maybe step 4 is solve for t. Pardon my handwriting, I'm using a stylus on a monitor, touchscreen monitor. But that says solve for t, my chicken scratch. So I'm going to do that by dividing both sides by 0.25. Okay, so you're going to be left with t equals the natural log of 90 over 50. And this is all divided by 0.25. Okay, so let's do that in our calculator. Okay, so here's my calculator, and I enter natural log of 90 divided by 50 divided by 0.25. And I get an answer of 2.35. Oops. So let's write that down. 2.3511. Okay. And again, we could, check our result by graphing. I'm not going to do that, but if we were to try to check our result by graphing, we would just graph the left side is 50e to the 0.25t, and the right side would be 90, and we would find the intersection, which I believe would happen at this 2.3511. Okay? Last problem. Question 3. All right, so we're going to solve now. This is tricky. You might be tempted to say, oh yeah, okay, first step is isolate the exponential, and you might do something like, all right, I'll divide both sides by 7, and I'm left with 0.129x equals 18, but this is wrong. No good. Okay, you cannot divide by 7, right? The 7 is attached to the exponent. See, number 3 is different than problem 2. See, 2, there's a 50 in front of the exponential. When you look at problem 1, there's a 75 in front of the 0.85. Problem 3, there's nothing in front of the exponential piece. Right here, 75 is in front of the exponential piece. 50 is in front of the exponential piece. Number 3, there's nothing in front of the exponential piece. So the first step is not to divide by 7. The first step is to actually take the log of both sides. So let me erase my scribble marks here, and we'll begin the problem. I got a little carried away here. All right, so step one is to take the log of both sides, and or you can use the natural log of both sides as well, right? So we'll say ln ln 18. Okay, so I took the natural log of both sides. Step two is going to be the rewrite. Okay, so I take the exponent and I place it in front. Okay, and now step three, I need to isolate the x. I'm trying to get x by itself. So let's take a different color here. And right, I want to get x by itself. So I need to, for step three, divide both sides by 0.129 times ln 7 on both sides. 0.129 times ln 7. Okay. And maybe it's good to kind of see this whole thing in parentheses. Okay. I'll put another set here. Okay, so what happens is the 0.129 cancels, the ln 7 cancels, leaving me with just the x. Let's go back to our red ink. Right, so I'm going to be left with x on the left side, but on the right side, my numerator is the ln 18, and the denominator is going to be the 0.129 times the natural log of 7. Okay, so when we enter this into our calculator, it's going to look something like this, ln 18, and then I have to really isolate my whole denominator, so that's why I have the extra set of parentheses, the 0.129 times the natural log of 7, and I have 2 parentheses open, so I need 2 closed. I press enter, and I get 11.51, okay? So let me write that down. And I'm going to round the last digit. Oops. Okay, so it's 11.5144. All right, so it's a little sloppy what I've done here, so let me try that again. 11.5144. Right, that's our answer. Right, and you know, I have a little bit of time here, so let's just quickly graph this. So I clear everything out. I'm going to graph the left side of my equal sign, which is the 7 raised to the 0.129x. I like to put my numerator in parentheses, or my exponent in parentheses. And then I'm going to have an 18 for my y2. In terms of a window, I know I have a straight line at 18. So my y max has to be bigger than 18. I'll use 25. I press graph. There's the left side of my equation. That's the 7 times raised to the 0.129x. And then the second equation is the 18. The intersections I can trace, number 5, enter, 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 11.5144. And I believe, right, that's what we've written down here. Right, 11.5144, 11.5144. Right, so you can see it worked. Again, if you're going to solve this by graphing, you have to sketch the graph, label the intersection. If you solve it by logs, just show me your steps. Okay? Thank you, and have a nice day.